This lesson is over solving equations with variables on both sides. When we have variables on both sides of an equation, we have to use inverse operations to combine them and get them on the same side. So our first goal when solving multi-step equations is to get all of our variables together, and then our goal, once we get them all together, is to then isolate the variable or get it by itself. The first example says, what is the solution of 5s plus 13 equals 2s plus 22? So we're going to go ahead and look at the equation. And if you notice, we have 5s on the left side of the equal sign, and we have 2s on the right side of the equal sign. Now, there are actually two correct or possible ways to, there's actually several ways to do this, but there's two ways to combine your like terms. One way, and both of these are positive right now, we have a positive 5s and a positive 2s. They're on different sides of the equal sign. So we want to cancel out our variables on one side, and then we want to get them all together on the other. Now, one possible choice would be to subtract 5s from both sides, which would mean that they would cancel out on the left side, and we would be left with our variable on the right side. That's a totally fine decision to make. However, if we subtract 5s from 2s, that's going to leave me with a negative term, and it's easier, I think, to work with positives if you can. So my choice for this problem would be to subtract 2s from both sides, and that's still the subtraction property of equality. I'm subtracting the same thing, 2s, from both sides. On the right side, 2s minus 2s is 0. It's going to cancel out. On the left-hand side, we have 5s minus 2s, which would give me 3s. We're going to bring down plus 13 equals a positive 22. And once we've combined our like terms, we're left with a two-step equation. So to solve that equation, I'm going to subtract 13 from both sides, giving me 3s equals 9. And then I'm going to use the division property of equality, dividing both sides by 3, to give me s equals 3 as my final answer. Now, backtracking up to the very beginning, if you would have chosen to subtract 5s on both sides, you just would have ended up with a negative 9 equals a negative 3s, and when you divide a negative 9 by a negative 3s, you would have still ended up with a positive 3. So there are two very correct ways to do that. Like I said, I just prefer to deal with positive variables if I can, so that's why I made the choice to subtract 2s from both sides. The next example says, what is the solution of 2 parentheses 3x plus 1 equals 4 parentheses x minus 5? This problem does have variables on both sides, but before I can combine my like terms, I have to use the distributive property actually twice here. On the left-hand side, we have 2 parentheses 3x plus 1. We need to distribute the 2 into both terms, 3x and a positive 1. So 2 times 3x would give you 6x, and 2 times a positive 1 would give you a positive 2. On the right-hand side, we have 4 parentheses x minus 5. When we distribute the 4 times x is 4x, and 4 times a negative 5 is a negative 20. Again, now I have like terms on different sides of my equal sign. Just like in the last problem, I'm going to choose to keep my variable positive, so I'm going to choose to subtract 4x from both sides here. 4x minus 4x on the right-hand side is going to cancel out, and 6x minus 4x is going to give me 2x. So 2x plus 2 equals, bring down a negative 20. Make sure that you keep that a negative 20. The subtraction sign becomes the negative. Now it's a two-step equation. I'm going to solve it by subtracting 2 from both sides, which gives me 2x equals negative 22. Divide both sides by 2, and you get x equals negative 11. The next problem says, what is the solution of the equation t plus 8 equals negative t plus 6 plus 2t? Now, in this problem, we actually have combining like terms on the same side, and combining like terms on different sides. You always want to combine like terms on the same side first. So if you notice on the left-hand side of the equation, we have t plus 8. There's nothing to combine there, so we're going to leave that alone and bring it down. But if you look on the right-hand side of the equation, we have negative t plus 6 plus 2t. We're going to go ahead and combine negative t plus 2t, which would give me a positive 1t or plus t. So again, on the right-hand side, I just combined my negative t and my positive 2t to give me a 6 plus t. I do have like terms. Both of these are understood positive 1t's. I need to get them together. The opposite of adding or having a positive 1t would be subtracting t from both sides. Now this is an interesting case because if you look at this, we have t minus t on the right-hand side, which would cancel out the t's. And we have a positive t minus t on the left-hand side, which is also going to cancel out the t's on that side. So actually right now I'm left with no variables left. On the left-hand side, I'm going to bring down a positive 8, and on the right-hand side, I'm going to bring down a positive 6 because that's what's left in the equation. But that's not a true statement. 8 does not equal 6. 8 will never equal 6. I've recently heard this called an absurdity, right? It's pretty absurd. 8 doesn't equal 6. That's common sense. We know that. So this equation actually has no solution because when you're combining like variables or like terms, they cancel out, and 8 does not equal 6. So when you're left with a false statement, or like I've said, an absurdity, there is no solution to the equation. There is no value that you could plug into t to get the two sides equal. The last example we're going to look at is asking us what is the solution of the equation c plus 6 minus 4c equals 4 minus 3c plus 2. Just like in the previous example, we do have combining like terms, and actually now we have combining like terms on both sides of the equation. Like on the left-hand side, we have c minus 4c, which would give us a negative 3c. And on the right-hand side, you actually have like terms as well. You have a positive 4 and a positive 2 whole number, and you need to go ahead and combine those right now as well. So again, on the left-hand side, I combined the positive 1c and the negative 4c to give me negative 3c, and I brought down my positive 6 equals, I went ahead and combined the positive 4 and the positive 2 on the right-hand side of the equation, giving me positive 6, and I brought down the negative 3c. Now my like terms now are on different sides of the equation. If you notice again, both of my like terms are negative 3c. To move either one of those to the other side, we would need to add 3c to both sides. Just like in my last example, my variables are going to cancel out on both sides of the equation. Negative 3c plus 3c on the left-hand side is going to cancel out, and negative 3c plus 3c is going to cancel out on the right-hand side as well. But in this case, I'm left with a positive 6 equals a positive 6. This equation we're going to say has infinite solutions because when you are combining like variables, they cancel out and 6 will always equal 6. Anytime you have something equal to itself, it's going to be called an identity. And anytime you're left with an identity, you're going to have infinite solutions. What that means is that I can choose any value to plug in for c, and the equation will always be true. I could plug in 0, I could plug in 1,000,000, I could plug in negative 3,976, right? And the two sides of the equation will always be equivalent.